Alright, the screwdriver is ready. I have the specifications nearby in order to show you the previously promised details, and let's start delving upon the product. Of course, I will turn it off, although this is highly unnecessary given its conditions. Alright, so since it's unplugged, I will get on quite quickly and take apart the battery. Of course, this is not entirely necessary, but I will do so. Okay, there are your typical Phillips head screws. They are quite nice because there are metal inserts in which they are placed. This is the battery. As far as I can tell, it's 100% operational. I have not charged it recently, but I'm entirely sure a test would show this possibility. And as we can see, there are 4 other screws that we have to take apart. So let's do so. Just in case you wonder, they were quite strongly twisted in their holes. So right now you're not seeing the full extent of force you have to use in order to take it apart. It has been previously taken apart in an attempt to see if there is something that could be done about it. Unfortunately, this wasn't the case. All right. We can see the backside and the internals, the circuit board. What surprised me when I noticed the backside, the fact that there seems to be no electromagnetic interference shielding on its back. And think about it, there are multimeters that have some sort of shielding in their back, but this one, which of course is a much more delicate and advanced measuring device that has advanced electronics, does not have such a thing. And also, as you notice over here, one of the clips simply broke. And I don't think it was wrongly assembled. So the casing can't withstand certain shocks, but it's not as durable as you may consider. What is interesting when you look at the UNI-T product description, it mentions the product as being lightweight. To me, this is not lightweight. It's portable, but it's not lightweight. All right, let's see what we can notice on the board and about the internal construction. I think that this may be the screen addressing ribbon, the screen addressing interface, which is quite likely given its width, and this one should be a connector for the keyboard. Overall, what I'm noticing, I'm noticing quite poor shielding. Of course, this is the part that is the most important one because it houses the high frequency electronics. But however, I'm noticing very sparsely shielding on other parts of the product. Also, as far as you can tell, there is no place in which it's obvious that there is CPU, and clearly such devices use a CPU, so probably it's on the other side of the board. Oh, you can clearly see over here, yes, we can clearly see the markings that were left by the screws, which is a bit surprising because I was expecting the product to withstand better certain shocks, but as you can see over here, the plastic is not quite up to the standard. All right, we are going to continue the disassembly, even though I am clearly not knowing all too well what these parts are doing. This is clearly a buzzer, probably done for the continuity test or in other situations where sound must be generated. This is one of the connectors used for powering the device, and it's clearly done so. It's the standard barrel, recessed barrel that you can see on the right side of the device. This is a connector that is not quite clear to me what kind of purpose it serves. So probably it's something for calibration. I don't know exactly what would be the purpose of it. I notice over here the standard gluing that is used for different products in order to make them better withstand shocks, but I always see such a solution as being a shoddy way of ensuring a good fixing, because ultimately what matters the most is soldering. So if they use that, I'm not entirely sure if they made all the if they paid all the attention to manufacturing. However, this is highly common, and in most devices you will see it. So it's not something that I will be placing too much emphasis on. However, in product that should be used as a testing equipment, I don't see that as being quite good. I can see here a coil, probably one that is being used with the power supply, because in general such coils you see near the power supply. A typical 8-pin microcontroller, another microcontroller which I think is a 16-pin model. Another microcontroller, some field effect transistors, probably used for power logic. I don't know exactly their purpose. Again, probably some other custom logic. So in order to disassemble further, I think we have to, yes, those screws are overly tightened, which is not particularly a pleasant observation, because such design choices clearly show that there were certain issues with the design. I mean, in general, you're not going to tighten too much or too little the screws. You're going just to ensure the correct amount of force. Oh, I'm noticing also, if you look over here, the way in which the screw has a certain way of wobbling, so when it's rotating, it's not making the perfect contact, which again is not quite a good telltale sign of a good manufacturing. You can see it's being dyed in blue, which is a common solution being used when you want to ensure that certain parts have a very simple way of proving if there was tampering on the product. Okay, this screw I think has much less problem when rotating, so probably it's not dyed as much, or the screw hole is being, or the screw itself is better machined. Okay, and I think right now it's mostly free, but let's take this connector in order to make sure that we reach the other side without damaging something, and probably we have to take out also this ribbon. I'm not entirely sure, we will see quite soon. Okay, so something is keeping the board from lifting, and I'm not entirely sure. Okay, so this one is to blame. All right, then let's see. Okay, it lifts, and probably we can lift the connector as well. And right now it should be mostly free to be taken apart. And right now we see all the interesting details about the board. As you can clearly notice, it's a highly integrated board. The power electronics is clearly located on the lower side, as you can see, due to the larger coils and other components that clearly point at this as being the filtering, the voltage filtering area. Probably this is the CPU, or if it's not the CPU, it's the flash memory. I'm not entirely sure if you will be able to see the markings on the chip. Yes, it's 1728.29 F1G08 ABAEA. And I'm also noticing something that looks like hairline, which of course is not mine, but it's interesting because it goes on to show. Could this be a bodged wire? No, I think it's just plastic. Let's see. It's just a piece of plastic that was probably not cleaned properly from the board. Okay, if you look at the board closely, and I hope you have a reasonable view of it, I'm not seeing any sort of particular detail that would point at the device's malfunction. Generally, you look for burnt parts that parts of the board that have changed in color from the color of the board to one that is mostly burnt. You don't see cracked components. So it's quite difficult to tell what actually happened, but I'm pretty sure that the internal logic failed. And this one, I'm going to read the marking, 7VP75D9ACE-MD, SHD, sorry. So probably this is another part of the logic, and I see over here two more that are actually too small to be read. However, I hope you will see them. Okay. Yes, that's the focus. I'm talking about this part in particular and this part. I'm pretty sure that something went wrong with one of them. However, I'm not very interested to find out, to spend the time in diagnosing this board, because I'm expecting the product to have the tendency of reaching more failures in the future, even if I would be able to repair it, which of course, as mentioned before, is beyond my capabilities. Right, so what can I tell right off the bat? I'm not experienced enough to judge a product based upon its board design and schematics. However, there are some details that do not quite point to a very high quality integration. Of course, it was an affordable product, but then again, I was expecting one that would operate at least, which of course is not the case. Soldering seems decent, but nothing to write home about in particular. And as you can see, I think you have all the details that you could, and probably a much more knowledgeable person would have a lot to comment based upon what is being seen over here. I will just make another cursory note. The same channel logic that is being housed in this metal casing could have been placed on the other and have the product well operational with two channels. I am pretty sure that this is a way in which they make product segmentation, and they simplify the way in which they create a product lineup, but I'm entirely sure that um, it's part of their design and approach. And I'm pretty sure that just about any manufacturer has different ways in which they address different markets and price points, and having a common base design to which they can adapt various components in order to create the whole feature lineup is quite frequently the case. And in case you are wondering, over here I'm noticing two ports that can be used to adjust the reading. So probably they are used for the test probes when operation under the multimeter feature is the multimeter capability, the digital multimeter capability is required. Right, so I think that my expertise is mostly stopped in this instance. I'm just noticing the differences between the left side that it is populated and has the only channel that this scope has, and the right one that is not fully populated. So I'm pretty sure that it's a cost effective design. Unfortunately, as I said, reliability is lacking. And what is left, as you can see over here, the display, which clearly is being addressed using these lines. And of course, you can clearly see that the protective foil has not been taken out of the screen. And the connector that probably is for the keyboard and the light that could be turned on when the device is operational. I'm seeing some shielding over here. It's quite a tough metal part, probably galvanized steel. Nothing to be said about its construction. And that's just about it. The product is not working and probably will never do so in the future. However, as I said, this is poor manufacturing quality control. And as you can see over here, since the device has experienced minor, let's say, disassembly attempts, it has some broken plastic parts. But keep in mind, the device was not operational even before any attempt at disassembly happened. So actually they are not going to matter at all in the grand scheme of things. Alright, now what I would like to tell you, because I promised, and it's only reasonable to do so, was the product's specification page. So to know what you could be asking for. And keep that in mind, the product was not having the specifications on the box. It will have in the description that you will see on the video. However, let me also present it and tell you my perspective on them. So 25 megahertz bandwidth. It's not a large bandwidth, but keep in mind that in most situations when you're not going to evaluate or test advanced equipment that operates at high frequencies and at high data transfers, this is not going to be an issue. In general, a device that has a higher sampling rate or a higher bandwidth, it is able to better follow signals at higher frequencies. And even those that are not at such a high frequency can also be represented with more accuracy. So in general, if you can strive for a device that has a higher bandwidth, you will use it. However, in most situations, 25 megahertz may be enough. Keep in mind that there are still oscilloscopes that have a bandwidth as low as 10 or 5 megahertz, and ones that were at 10 megahertz could have been used with previous analog TV technology. And keep in mind that that was quite quite an advanced requirement when servicing. So in general, unless you design specific products, 25 megahertz is not a bad value in itself. One channel, as mentioned, in general with two channels you have more versatility. You can also use the math function, so you can use subtractions, additions, multiplications, and so many other functions that help you better understand what is the behavior of the circuit you're testing. The sampling rate is 250 million samples per second. This is not a high value. Keep in mind that there are 1000 million samples oscilloscope. It's mostly on the mid-range and shows a device that probably is useful to around 125 megahertz, because in general the sampling rate should be at least twice the frequency you're going to notice, at least twice. Of course, you're going to have some issues with precision, and this means that in general 4 times would probably require you to have enough sampling points to be sure you have a good waveform. So in general, this is a rough estimation of your performance. Rise time 14 nanoseconds. I can't tell well if this value is really that good or not. Vertical scale 5 millivolts to 20 volts per division. This is roughly in the ballpark of most oscilloscopes. They are not made for very high voltages, and the very low ones generally go to 1 to 5 millivolts. There may be some that also have the capability of having even more resolution, but I think that 1 millivolt is reasonable. So 5 millivolts is not that bad in terms of accuracy. Time-based scale 10 nanoseconds to 50 seconds. In general, high or long time bases are not going to be particularly useful, because most of your changes will probably be occurring at with a higher rate. So probably 1 second would be your most likely limit at which you need to go in the sense of how long it should be. And the lowest one, 10 nanoseconds, yes, I think there are ones that could go to 1 nanosecond or even less. But again, the issue is if you are going with the time base so low, you need to have a very good accuracy on the scope, because if your scope is using a feature that averages certain values instead of rightly reading them at a specific time base, it means that you're going to have delays, and you're not going to have a very high reliability. So in general, this is not going to be highly useful if the time base cannot go that low with also the same capability of having good and precise readouts without any sort of interpolation. Trigger edge pulse video slow. It's custom to have also edge pulse external triggering. However, this oscilloscope doesn't have the possibility of being externally triggered, and having an external trigger would have probably be much more useful when testing digital equipment, but this is not the case. Interface mini USB, yes, sorry, I mentioned micro USB, my mistake. It's quite an old standard. I'm not entirely sure why they use mini USB and not micro USB, because even by 2018 it was quite an old design to use that sort of connector. AC and DC current, AC and DC voltage. The battery pack, as mentioned, it's 3.6 amp hour. The TFT LCD is having a resolution of 320 by 240. This is standard, and there are many oscilloscopes on the market today that have the same display resolution and with display of 8.9 centimeters in diagonal. I think it's roughly in the ballpark you are expecting, even one that is available today. So it's quite reasonable. Weight 900 grams. Yes, I was surprised to find out that it's a bit less than 1 kilo, but probably due to the size and how compact it is, it feels as it would be slightly heavier than 1 kilo. And it has the power cord, adapter, USB cable, CD, and test leads. And keep in mind that this product retails for 300 to 360 euros, 300 or 380 probably US dollars. So I think it's a bit overpriced considering the current market situation and particularly the reliability issues. I'm not entirely sure if UNI-T has solved the reliability issues in newer models. It has a better revision or any sort of mitigation that would solve the issue of the product going bad. But if it's not the case, then it's severely overpriced. I'm also having to make an additional note. Most reputable manufacturers make a recall of certain products when it's noticed that they have manufacturing defects. However, in the case of UNI-T, I wasn't expecting particularly for them to have this approach, and as it seems, or as I read up until now, there hasn't been any sort of information about a product recall for these designs. And this goes on to show what is the level of feedback or of client service that they are going to show. It's typical with most manufacturers that are not reputable, and UNI-T clearly is not going to show any better behavior in this respect. So I think that it's extremely disappointing for a product to end up like this with an age that is less than 3 years, but this is what happened. And I hope that more of you who are able to see this product and understand better what it is all about will think twice about purchasing it in the future. And I hope that you have a better grasp of what were its design flaws, because not only the fact that it failed to operate after 3 years is relevant, but also the fact that internally you can see some details that point to a less than great design. So I hope you enjoyed the video, saw what it was all about, and hope you will find other videos just as interesting in the future. So thank you very much for watching and have a pleasant day. Just in case you wonder, do not buy this product or one that is in the same range, unless you know all too well that they have solved the issue.